So this is like a mini investigation, meaning I'm just going to draw a sketch of each of the following functions. Now, we're very familiar with these first two functions, so I'll just make a quick sketch. Now, when we make our sketches, we want to always put our x and our y axis here. I don't know why I made that x so small. It's a linear function, and it's just 1x, so it's 1, 1, 0, 0. It's that wonderful y equals x function. It's a straight line. Do my best here. There we go. That one we're well familiar with. This is also a familiar one. And it's our friend, the basic quadratic, meaning it has a vertex at 0, 0, 1 squared, which is 1, 2 squared, which is 4, and it's symmetric. We've done this since grade 10. We should all be very familiar with this now. It's the basic quadratic function. Okay, then we have this one. Now, you may be familiar with this one, or you may not be, so we'll take a look at it. X cubed. What does the cubic function look like? Well, when I put x equal to 0 in here, I get 0. I know that. 0 cubed. 1 cubed is 1, just like. But here's where these two functions differ. When I put negative 1 into the cube function, I don't get 1, positive 1, I get negative 1. So it goes in two different directions. 2 gets really big really quickly. I'm not even going to put that up, so way up there at 8. So it actually looks like this. It's a little squiggle there right at the 0. And lastly, I'm going to, now this one, x to the 4th, which you're probably not that familiar with. But if you put it into Desmos or some graphing software, you would find 0 to the 4th is 0. 1 to the 4th is still 1, and so is negative 1 to the 4th, 1. But 2 to the 4th is very, very much bigger than 4. It's going to be 16, so way the heck up here. And you'll find, oops, that's not a very good drawing. It's very flat on the bottom, much flatter than the quadratic. Although it looks a lot like the quadratic, it's quite flat near the vertex. So, and if you continue on, you can graph a bunch of these using some kind of graphing technology. You'll find that the plain odd ones look like this, except slightly flatter and steeper. And the plain even degree x ones will look like this, only flatter and steeper. So looking at these basic functions, polynomial functions, and we call them basic because they're just the one term, we notice some basic properties. And one property that we're always interested in with functions is the domain, the possible x values. And if we look at all of these functions, in the x direction, the functions keep going forever. That's because any x can go into these functions. There's no stipulation saying, oh, this will not exist or that. It's always going to work out. So the domain is always XER. So we have the domain of all polynomials is always x is an element of R. That's how we write that. It means it can be any real number. The range of an odd degree. Now odd degree, remember degree is the exponent. The odd ones would be 3, 5, 1. Is always YER. So let's look up at our thing again here and look at our odd ones. We have an odd one here and here. They're odd. And notice how they keep going. Like if you look in the Y direction, they go forever. And that's why the range of an odd degree polynomial is always YER. The range of even degree polynomials, though, is not the same. So let's take a look at that. These two are even, the 2 and the 4. The range always has an upper or a lower boundary. In this case, there's a lower boundary. But if we were to reflect it, it would have an upper boundary. But they never go in both directions. So we say the range of an even degree polynomial must have a lower bound or an upper bound. So we would say the range of all even degree polynomials have an upper or a lower bound, but not both. We also notice, if we look, and we'll look back in a minute, polynomials have no asymptotes. Now, asymptotes are those lines where the functions will approach but never reach. We do not have that with polynomial functions. And lastly, we have the nth finite differences of a polynomial will be constant. So what that means is, and you've probably done this with quadratics, when you were doing quadratic functions, you know that the second finite differences, if you took the second differences from the table of values, you would get a constant number. But if you have a cubic function, an x cubed function, the third finite differences will be constant. And we'll look a lot more at that at a lesson coming up. So remember, polynomials have no asymptotes. The even degree ones have a lower or an upper bound in their range. The odd degree ones have no bounds on their range at all. They go up and down in both directions. And the domain, very important, the domain of all polynomials is always x is an element of R.